Yeah, faking at level 1. So I will try to keep it short because we are just a bit over time and it's okay, yeah. Then just go to presentation mode. I'm Thomas. Some of you might know me, so from other conferences, from this conference and from some consultancy services. I was speaker on various conferences like Hack in the Box and Black Hat and so on. And I've also published some security advisories regarding embedded devices and also some PLCs. So the outline of my talk is some foundations of operational technology of embedded devices and a bit of penetration testing in operational technology networks. Digital twin construction that might be new to some of you because that's not a that common topic in the cybersecurity field, but it's very useful. Also security testing, that's clear. We are on a security conference today, and a conclusion to some of the topics. So what are the foundations? Just a quick overview. Operational technology is also known as OT, so I guess a lot of you know that. Containing some RTUs, PLCs, HMIs, so what we heard in the previous talk, and also engineering stations, SCADA servers, historians, and yeah, a lot of mechanical and yeah, other parts which are moving in the operational technology network. Another really important term is IoT, so also known as embedded device, also known as whatever Internet of Things. So it can be a printer, it can be a smartphone, it can be a router and so on, smart fridge, and what else you want to connect to the internet nowadays. And also industrial Internet of Things, which is a bit different to IoT because it's Internet of Things in the industrial field. So it might be some networking hardware, might be some sensors, actuators, or other devices in the industrial environment. And another really, really important term is digital twins. And for digital twins, there are different definitions. So you have a lot of digital twins which are just, yeah, twinning your physical environment. So if some I don't know, some physical process has been mapped to a digital twin, you see just how it works. You see just a schematic image. You can see some mechanical parts which are moving. But digital twin in this talk has a different definition. So it's a digital twin of the operating system of the embedded device, and not a digital twin of the process itself. So in the early days, we had field bus technology in the operational technology network, and PLC programming via the COM interfaces, RS-232 and so on, and you had limited memory, as we have heard in the previous talk. And the supervision was via analog technology, light signaling and some buzzers and some whatever you can imagine. And yeah, now it became smarter nowadays. Not all of them, of course, because you know, you have a lot of old devices in the network. You have a lot of legacy software and so on. But nowadays we have PLCs with Ethernet connection, and which much more computational power, memory. You have managed Ethernet switches, you have routers, firewalls, and so on. So the whole network infrastructure in the operational technology network. And you have the shift from traditional field bus to TCP/IP stack. So nowadays, we have heard it before, Modbus. Modbus TCP is one of those candidates, which has been shifted from direct serial connection to, or bus connection, to a new media, Ethernet. And yeah, it's just using the TCP/IP stack like in the traditional way back in the 90s. And yeah, that's really unsecure because it's unencrypted and all the other things which are implications of that. So you have a lot of differences between IT and OT networks. So you can read it yourself. So you have a lot of network traffic and high bandwidth in IT networks. You have low bandwidth and medium network traffic in OT networks. And you have also to deal with hard real-time versus soft real-time. So that's sometimes a really crucial thing. If you don't get the measurement value from a sensor in real time, then it's useless if you get it in 5 minutes later, because then, it might be completely different now, if it's a temperature value or if it's some other measurement value, and so on. You have shifts from updates, so which are sometimes running daily in IT networks, and versus OT networks, you have upgrades only on yearly maintenance base. So how do you do a typical OT security assessment? Be careful, log all the network traffic, don't use automated security scanner, and be careful, of course. And if you look at the Purger model, also known as PERA, so Purger Reference and Enterprise Architecture, a lot of OT networks are structured like this, from level 4 down to level 0. The talk is called Faking on Level 1, so you might know what we want to fake. All those devices, which you can see here, you can imagine what they do. So on level 4, you have file servers and all the IT enterprise systems. On level 3, you have engineering stations, you have historian, you have SCADA servers, and so on. On level 2, you have HMIs, also SCADA servers and other HMIs where the engineers can put some input into the field devices, which are acting on level 1, which is the control network, so all the PLCs, all the RTUs, all the I/O processing or pre-processing, which goes up to level 2 and so on. And on level 0, you have the field devices which are connected directly to the PLCs, to the RTUs, and so on. And if you want to do some kind of OT security assessment, then you have to do things like information gathering, like in traditional IT networks, doing some kind of review of the blueprints, if you get them, collect information about systems, including software firmware versions, and so on, to find vulnerabilities, known vulnerabilities, and maybe new vulnerabilities. Also sniffing the network traffic via TCP dump, Wireshark, or other tools, where which helps you to conclude which devices and which protocols are in the network, which are acting in the network. And if it comes to active testing, then again, do not forget to log your network traffic, because if something breaks during the security test, then you have a problem. And scanning devices with ICMP in the network is a good idea, because it gives you a first overview of how many devices are connected in the network, and doesn't break a lot of things. So usually no PLCs should reboot if you just do this. And you can also scan for selected ports if you're very brave, but be careful. And testing for typical vulnerabilities is only a good idea if it's during a maintenance window, if it's in accordance with the customer, and if you are sure that you cannot really break a lot of things again. And there are also tools like Tenable OT. Some of you might know this tool, which is a specialized tool to scan in OT networks. I'm not really sure if they have good lawyers, so if you break something, I think you will be responsible for this, but I don't know. And of course, you have risks during the testing, denial of service, destroyed devices, affecting power supplies if it's done in, common power supply, if it's done in critical infrastructure, and of course, human life. So you should know if you can break something, because it may have some implications. So maybe it's less harmful in OT scanning software. So if it still arises, the problem, if you're using Tenable OT, then yeah, you're responsible. And yeah, there are also a lot of solutions which can use, but yeah, such techniques are sorry, just forget this this slide. Just a recap of what I've said before. So let's switch to the digital twin construction. So why should we use digital twins of OT, IoT, and embedded devices? If we would just create a digital twin out of a real device, then it would be really, really interesting to just test this digital twin instead of testing the real device. So just assume we can extract, download, or somehow other, in another way, get the firmware from the device of interest, analyze the firmware, and prepare it for virtualization, so for building a digital twin, and start the desired virtualization environment, platform, or digital twin on an infrastructure, and just test it. So if you just run it, just test it. And some tools which are known and which may be also unknown are Emox, Chilling, Medusa, or Thermodyne, which you can use for creating a digital twin. And if you have a digital twin of such device, you can do pretty much everything. So you can access to the kernel, you can access to the userland, you can have access to the running processes, and those frameworks are offering a lot of architectures which are possible to be emulated, and also different levels of emulation. So Chilling is more like a binary instrumentation framework, whereas Emox and the other ones are frameworks or tools for emulating the whole Linux environment and its userland. So emulating the kernel is really hard. Is possible with Chilling, maybe, sometimes. But emulating the kernel can be really cumbersome because you don't really know which devices have to be attached to the emulation or to the kernel or to the CPU to really bring up the device. So it's sometimes really cumbersome to really emulate everything. So sometimes we have to live without some IOs and without some parts which are part of the embedded device which should work. So if you have a physical device, then you have a chipset, IO, and firmware. If you have a digital twin, then you have emulated chips, spare IOs, and the emulated firmware. And if you do it, you can get a whole idea what processes are running, what ports are open, and which software is running, and how it behaves, and which problems and vulnerabilities they may have. So it gives you a really good overview of the whole device. So the pros and the cons, so you can think about it. It's never a 100% clone of the embedded device. So that's clear. And the thing is, some of those OT devices, which I've mentioned before, are not able to be emulated sometimes because it's only really widely usable on embedded Linux systems. If you want to do it on other real-time operating systems, then it's really hard, So sometimes next to impossible. You can do it with enough time, but it's really, really hard. And that's the reason why all those tools are focusing, or most of them, are focusing on embedded Linux devices. So yeah, just jump into a quick demo because I guess I'm a bit, oh no, I'm in time. And look at one of those digital twins. So you can see the console of such an embedded device, which you wouldn't see at all if you have only the physical device. So those 2 devices are currently running and still active. If my hotspot is, yeah, it's working fast. And I'm doing it with Medusa, so I've shown you a bunch of other tools, open source tools too, which you can use for that. And I'm connected via WireGuard, so I'm connected via VPN to the network. And you can see some Chinese characters, but I can switch it to English so that it's possible to use it, at least for me. And you can see it's a bit slow because of the VPN connection to the network. But that's a full emulated device where you can access to the web interface, where you can look at the settings, or set some settings, look at the system, settings and whatever, what you want to look like. And also the cloud service, which is really interesting because if the device is connecting to a cloud just autonomously, then sometimes it also works for digital twins. If you create a digital twin out of a firmware, and then you can connect to the cloud of the vendor. And if it works just by using a firmware update or a firmware update file, which you can grab from the website of the vendor, then it shouldn't work because then you can just access to the cloud. And yeah, for OT devices, that's a bit funny, but sometimes it even works. And the next one is Hirschmann. Maybe some of you know Belden and Hirschmann, so that's a common brand also in the OT network. Oh, it's now reconnecting because of the slow internet connection. But you can see you can just look at the settings. You can just look at some diagnostic functions. You can find some vulnerabilities in diagnostic functions, but it's not published yet, so I cannot show it to you. But maybe next month, because they will release the security bulletin next month. And yeah, very often, it's delivered from a third party. So those devices, those from Hirschmann and also from Siemens and from other vendors, are really often produced, or the firmware is really often produced from a third party. Sometimes the hardware is also produced from a third party, and sometimes you see 2 different vendors, and if you open the devices, then the hardware looks like the same, and it's also the same part numbers and the same numberings and the same, and it's from the same fab, and it's from the same designer, but they are competitors, so really funny, really funny. So I have done it for Hirschmann. I have done this digital twinning also for Delta Electronics, for ProSoft, just name it, for Red Lion, so for the Entron series. And all of them are on level 1 or on level 2. So it's networking infrastructure, or they are PLCs. And you can imagine, if you just emulate a PLC, with all of the services which are running on the PLC, and if you grab the software which you would use on the engineering station, which connects via the network to the whatever programming port, it may be some IEC 61 whatever port, then you can look at the communication, you can look at the process, and you can look at the software, and you can inspect all of them. So you can ultimately find all vulnerabilities which you can find, except on a kernel level, but that's really nice. And I've also done it for Moxa devices, and that's a really funny story because I just downloaded the firmware, emulated it. They asked me, hey, what's your provider? What's the provider which sold you the device? And I just say, oh, it's just emulated. Afterwards, I looked at the price table, and it was 10K, so a bit more expensive. And if you don't have to buy it, and you find command injections and send it to them without buying it and without having some kind of provider, without having some kind of reseller, then it's really funny. And published some advisories for the other devices, which I also have shown now, and also currently pending Delta Electronics and Hirschmann. Hirschmann will go out pretty soon, but Delta Electronics is a bit unresponsive, so yeah, just let's see. And the reactions are also the same: deny, no reaction, and endless ping pong, like you know it if you report some kind of vulnerabilities. But for digital twins, you have a special case. So vulnerabilities get not accepted because it's a controlled environment and it does not apply to our device. So what do you have to do? Do not mention that you have tested on a digital twin, and just mention it afterwards if they have fixed it, and then it's okay. So the conclusion is just if you want to do comprehensive security assessments, they are also always challenging. Digital twins are really nice to enable pen testers to build a twin of the device the pen tester wants to test, and you can clone it. If you use it for OT devices and if you use it for OT networks, you do not harm it, and you can pen test the device for, let's say, 70 or 80% if the emulation is working, if the digital twin is working, and find security bugs which you would also find in the network. But in the network you can crash, for example, 200 PLCs, and then it stops working, so it's not really fine. But if you have a digital twin, then it's really nice because you don't harm the network. And if you want to find new vulnerabilities, you can analyze them really precise in the process, on the process level and everything else, by using a digital twin, because sometimes you just don't really have access to the real device, to the console of the real device. And yeah, that's a really big advantage. And yeah, no big news. So you have responsible and not responsible vendors, but we all know that. So if you have some questions to me, then just ask me. I will be around for the rest of the conference. And we look for people. We need colleagues. We are programming the solution for the digital twins. It's really new, and it's really innovative, and I love it, so it's really nice. But we need motivated people, and that's really important. So thank you.
Thank you, Thomas, for your enlightening presentation. Great. Other questions? Yeah, once again, you, fine.
Love it. Thank you so much for your interesting talk. So I'm wondering, because it seems from the devices that you showed that you have mostly emulated network devices. So I'm wondering also which PLCs in specific have you emulated?
So PLCs are always challenging, so I have to admit, but I've emulated, for example, a PLC from a South American company which is called Altus Automacao or something like that. I've also emulated Vago PLCs, so which are more known. But I think you're asking for Siemens PLCs, and they are using a real-time operating system programmed in C++, which is not really easy to emulate. You can try it with G-Link, but that's a real challenge. And no, I don't have emulated those PLCs.